Hi, so this is going to be a quick tutorial on how to use nbphysics, a 2D physics engine that I made in GameMaker. So what is nbphysics? It's a hybrid engine. It's made inside GameMaker with the GameMaker Studio 2 LTS version. So this is the one that I tested it on and that I made it with. So as a little disclaimer, it should work with the regular GameMaker, but I haven't tested it. But yeah, so NB Physics, here's a little bit of like a showcase of some of the things you could do with it. There's rotated rectangles, regular rectangles, and circles. You got forces, contacts, all that stuff. Um, all within the engine. You can see how it works by checking out the code and everything. So yeah, if you don't want to use GameMaker's built-in physics, maybe, or you want to see how a physics engine works potentially, you can check it out. So you can go to this URL. It's on my repository. It's the nbphysics. It's on GitHub. And yeah, if you want to download the source code, you'd go here and download zip. Or you can just download the release version here, which has the local package that's ready to be imported into GameMaker. So that's what I'm going to do. I'm going to do this one. I'm going to click it here. A little bit of description, some of the features it has. I'm going to click on nbphysics .yyMPS file, and here it appears. I can go to it, and here it's in the downloads folder, ready to be imported into a GameMaker project. So the next step is to go to GameMaker and make a new project. So I'm going to create, I'm going to call this project physics demo, and I'm going to place it in the tutorials folder. And there you go. Okay. And I'm going to press play real quick just to show you that it's a blank project. All right, so this is going to be an introduction video. I'm going to show you how to import the project, how to import the physics engine, and how to move a rigid body around, basically. So the first step is to import the actual physics engine. So we're going to go into Tools, Import Local Package. We're going to find the package under the Downloads folder, nbphysics, and open. All right, so it comes with all of these different files. There's also some demo folders with some, you know, objects here that are used in the different demos. So I'm not going to import any of the demo stuff. I highly recommend checking out all those demos, especially the platformer demo. But yeah, I'm going to only import the bare essentials, which is for sprites, these three sprites here, just for rectangles. For scripts, it'll be these two vector, these two structs for math stuff. You got a 2x2 matrix and a vector 2 matrix. I mean, no, not matrix, vector 2. And then some physics scripts, some for general functions, as well as some structs for the different things that's necessary. And then the big ones, the three objects, the physics world, the rigid body, and the triggers. So those are the three things the three folders I'll be importing. So there you go. All right, so when I press play, it should still be the same. Nothing has been added to the room. So, all right, we've imported the package, the physics engine. The next step is to um, put a physics world and a rigid body into into a room. So that's what we're gonna do. First, I'm gonna put a physics world into the room, and real quick, I'm just gonna show you when you have a physics world, it will display something on the top left corner as well as how many triggers and rigid bodies are in the current room. Right now there's 0. But when I put a rigid body here, I'm just gonna real quick make it big just so we can see it. Press play. It will automatically account for that rigid body in the counter, and it'll show it here. So if you can see this pink dot here, or purple dot, that indicates that this rigid body is asleep. All rigid bodies start off asleep unless you manually set them to awake, but they will automatically get like woken up if a force or contact is applied to them. So just a little heads up there. All right, so that's a rigid body. Hey, it's simple, but nothing was happening to it, right? All right, so the next step is to apply a force to the rigid body. But first, instead of applying a force to this one specifically, I'm going to make another rigid body and have it inherit from this rigid body so that we can essentially edit this one without affecting the base, like the parent class. So I'm going to call this O player. Okay, and I'm going to set this player sprite to just be the same as the one that's used for rigid bodies. And the parent will be the rigid body here. Okay. So we go here, take this one here, I'm going to place the player here. And I'm going to just make it bigger just so we can see it. Doesn't matter what size. Put it here. Okay. So the player is now a rigid body, right? Oh, but when you inherit from here, what sort of things can we change so that the player is different? Well, if you look into the rigid body and check out the create, we can see a bunch of different properties that essentially represent the rigid body, right? So physics objects can be described with a mass and a shape and an orientation and general physics properties that will define what happens between interactions. So here we have an inverse mass. It's stored as an inverse mass instead of a regular mass because it's quicker to multiply than to divide in per frame. So that's why you would usually divide a mass every frame to calculate an acceleration. But yeah, that's why this is here. So yeah, inverse mass, something you can change. The shape as well. Bounciness. These two, whether or not it's awake and whether or not it can ever go back to sleep. The gravity, dampening, which is a friction that's applied every frame. Some collision stuff, like for collision layer checking, and generators and triggers. Okay, yeah. So the big ones that I'm going to be talking about this video will be the shape and waking up, and these two, dampening and gravity. All right. So right now, when the player starts, they are asleep. Okay. If I apply gravity to them, or set the gravity to be 20, for example, downwards, it will not do anything because it's asleep. So you first have to wake up the body by going nbp. If you notice that the actual autocomplete isn't happening, in my experience, just closing GameMaker and opening it up fixes it. So I'm going to actually do that. Sorry. And I'm going to go like that. Real quick. That happens sometimes whenever you import a package, in my experience, at least for this. And now when I check MVP, there you go. Now it has autocomplete. I don't know why it does this. MVP, we're going to set awake. So this, we're going to have to pass in the rigid body. In this case, it's self.id, which is, or just the self. And true, we want to wake up. And then we're going to also, because it's a player, can sleep to be false. Just so you never want to like not process physics for the player. So yeah, with this, the gravity should be applied. There you go. Okay. But this is going to be top-down stuff just because it's easier to, so we're not going to have gravity. So we'll just wake up. That's how you wake up a rigid body. If you don't have this and you apply a force to it, over time it'll go back to sleep. So that's something to keep in mind. and that's for performance reasons. It helps with performance pretty well. Okay. What else? What else? What else? So we're gonna go check out real quick the rigid body here. Not the rigid body. Here. Okay, so the next thing, the shape, I guess. I'll show you the differences here. So if I rotate this player and I press play, the actual bounding box is what's used, not the sprite itself. This is because by default, the rigid bodies are just rectangles. If you want to change the type of shape, there's three supported shapes in the physics engine. There's rectangles, rotated rectangles, and circles. So if I want to make it a rotated rectangle, I would just go into the actual body here and set the shape. So we're going to use nbp set shape. I really recommend using this function versus just setting the shape, because it also updates the orientation matrix, which is used for physics calculations for the rotated rectangles. So yeah. Okay, so we're just going to set the shape. It needs the rigid body, so go self.id. And the shape is going to be nbp shape dot. We'll just go this one first. And show that now this one's highlighted. So it'll use this for the collider. And lastly, the circle. It'll use a circle. So yeah, that's how you set the shape. Next, we're gonna go and what else is there? The last thing is damping. So damping is the friction value, but you can't even see that right now because there's no forces. So I actually am going to show you how to apply force. So whenever physics is being updated, it occurs in the physics world. Every step event, the physics world will essentially run physics on all the rigid bodies. And then it'll clear all of the force vectors that are being applied to the rigid bodies. So you'll have to recalculate forces every frame. So because it's functions like this, you can add forces to a rigid body essentially anywhere, and it'll apply to the rigid body eventually. If you if you add your forces in the step event and this already runs, it'll just apply to the next frame. So I think that's pretty cool. But we're gonna add forces in the begin step just so that it's easier to understand what's actually happening. So yeah, I'm gonna go into the player. I'm gonna go create step, begin step, and here I'm going to add a force, add move force basically. All right. So first I'm going to create some sort of vector to hold to the actual move input or movement. Just going to go move input is a new vector2. This has an x and a y. That'll just hold, the direction that we're inputting our movements. So move input dot x is going to be equal to keyboard check the positive direction of the movement in the horizontal, which is going to be d, minus the negative direction, which is going to be a. And we're going to do the same for the y, except the positive direction is s and negative is w. All right, so this is the actual direction, but on diagonals, the actual length would be longer, so we're going to have to normalize that. And luckily, there is a function for that in the vector2 class called normalize, which basically, let me see where it is. Here you go. It gets the length of the vector and just divides the vector by it so that it's always of length 1. Unless it's a 0 vector, then it'll just be 0. Okay, so we set the actual direction of the move input. Now, because we want this to be a force that's being applied to the player, you also want to scale it by a value that is representative of the strength of the force. So we're just going to go move strength is going to be equal to 20. And we're going to scale it. So this multiplies every component by this number. All right, so we have our force vector here, the move input. Now all we gotta do is just add this force vector to the rigid body. So add force. This is where we use a general function, nbp add force. So you can either use add force, where you pass in individual components, x and y, or the add force vector, which you can just pass in a vector. So you can first pass in the rigid body, and then the vector itself. And there you go. Calculate the vector, apply the force vector, and things should start moving. And there you go. That's how you apply custom forces to rigid bodies in this engine. Okay, and one of the other things I was getting to is rigid bodies have a dampening value which affects friction. If you noticed, there was almost no friction on movement. So if I press right or left, it'll just keep going, slowly slow down because of a number of dampening. But if I change the dampening to be lower, closer to 1, um, it'll slow down with no inputs. This is a quick way to have friction in your game. Yeah, so there you go. That is dampening, gravity, some of the easier stuff for customizing rigid bodies. In the next couple of videos, I'm going to go more so in depth on force generators, how to use general forces rather than a custom force like this one. Contact generators for collisions, because right now bodies will just pass through each other. But if you want to add collisions to happen, you have to manually set that up. And how to use triggers. So yeah, thank you for watching, and I hope to see you on the next one.